possibly. So let's quickly brainstorm. What are all the different ways that we can graph lines?
Point slope form.
Point and slope form.
Y equals mx plus b.
All right, hold on, slow down. One at a time.
Yeah, bro. I don't know the names of them, but I know.
Point slope form. What is point slope form?
Y1.
No. Y minus y1 equals m times x minus x1, right?
That's what I was getting at.
Yep, hold on. Let's quickly keep talking about point slope. If it's written in point slope form, the things that you would get from it would be the point, which would come from this x value and this y value, right? And then the slope. So can everybody plot a point on a coordinate grid?
Yes.
And then could you count rise over run from that point?
Yes.
Hopefully. Okay. All right, I heard slope intercept. So let's make that number 2. Slope intercept form, which is y equals mx plus b, which is probably our most common that we're used to doing, right? My b is the y-intercept, so I would start on the y-axis, put a dot there, then do my rise over run for my slope from that point there, right? Okay, what's another way?
Standard.
Huh?
Standard form.
Standard form, and why would we put something in standard form? It is a form, that is correct. So standard form is when you have both your x and your y term on the same side of the equal sign.
Oh, if you're like.
But if it's written in standard form,
Problems they're like.
from here.
You have adult tickets and child tickets. And
Yeah,
both
right.
come out to $100.
Usually when something is written in standard form, the best way to utilize that is to find your x and your y intercepts. You guys remember the old cover-up method? Find your x-intercept, cover up the y, solve for x, put a dot on your x-axis at that number, cover up the x to get your y, put a dot on your y-axis, then connect your x and your y or intercepts together. So usually when something's written in standard form is when we're looking for our x and y intercepts. And what's the last way? This is like the most elementary, which you probably learned for the first time of graphing lines. Not a number line.
No, the
X, Y tables. Remember your good old X, Y tables?
Wow, right.
Plug it in, get some points. Just like that.
Oh, those like tubes.
Like
that
this.
Are in and out. Oh.
Pick some X values, plug it in, get the Y values, right?
Classic.
Classic. Table of values. Stem and leaf plots is a way to display quantitative data. All right, so you are going to be required to, 1, be able to find x and y intercepts. But when it comes to graphing, like on your quiz on Monday, if it says graph, you can pick whatever of these methods you want to choose to graph it with. Okay, so that's up to you. If it specifically says find the x and y intercepts, then make sure you find the x and y intercepts and tell me what they are. Okay? All right, so here we go. Let's do some examples. First one, find x and y intercepts, and then graph. So we have 4x minus y equals -3. We need to find both the x and the y intercept. After I find the x and the y intercepts, I'm going to graph them. Then I will connect them, and now it'll make me have my line. The reason why I can easily find x and y intercepts here is because it is written in standard form. Okay, so let's find the x-intercept first. So I'm just going to organize myself here, x-intercept. So when you are finding your x-intercept, you let your y equal 0. which means it goes away, right? So if I plug in 0 for y, I am left with 4x equals negative 3. So my x-intercept would be at x equals negative 3/4. How do I write that as an ordered pair? Good. Not negative 3/4, 0. Is that what you said? Yeah. So my x-intercept, I want my answer written as an ordered pair, negative 3/4, comma 0, would be the point where the line crosses the x-axis. Now let's do the same thing for the y-intercept. So for your y-intercept, we're going to let x equal 0, which means it goes away. So now I'm left with negative y equals negative 3, which would get me positive y equals positive 3. How do I write that as an ordered pair? 0, 3. Good. So now make a really quick, lazy xy axis. I'm going to go 5 units in all directions. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So negative 3/4, 0. That's negative, what, 7.75? So maybe right about there. 0, 3 is up here. As best as you can. Or if you're one of those OCD people, use an actual straight edge. Oops. I'm trying to make your line as straight as you possibly can. Make sure you put arrows on both ends so it goes on forever. Yes?
What if you just subtracted like 4x and then put it in a different form? Like y equals 4x.
That's fine. You would get the same, so you would get a y-intercept of 3, and then you would get whatever your slope is. But since I'm specifically looking for x and y intercepts,
Okay.
yeah, if I just gave you that equation and said just graph it, then you are more than welcome to do that. But if the directions are asking for x and y intercepts, then leave it in standard form. Okay? Are we good with that? Yes? All right. Moving on. So let's use the same problem. Now find the slope and the y-intercept. So now we are going to get y by itself. So now I'm solving for m, and I'm solving for the b. So now, quick manipulation. The first thing I always look for is my y term. Is my y term positive or negative?
Negative.
Negative. If I move it to the other side, it will become what? Positive. So I always just kind of just move things in my mind. So if
Yeah,
this
you just
confuses
subtract
any of you
4x,
guys,
and then everything's
let me
positive.
know. But if I move this over, that means then I have to move the negative 3 over. And what would the negative 3 become on the other side? A positive 3, right? So then I get 4x plus 3 equals y. Did everybody see that? Did I throw anybody through a loop?
But now your variable's on a gross side, you know?
Well, then I can go like, I can flip it.
Yeah, but if you just subtracted 4x and you have all negatives, and all negatives means it's all positive.
True.
So you're going to skip the step.
So if you don't like that, and you want to go with John's method, because he likes his y on the left the whole time, so then we can move the 4x over by subtracting it. So then we get negative y equals negative 4x minus 3. Divide out your negative. That's fine, totally fine.
Totally fine.
But if I just kind of go, and then it's there, that's what, because my brain's just doing all the movement for itself. Okay, so what's my slope?
4.
My slope is 4. What's my y-intercept? 3. Good. Huh?
Oh, just the floor is cold too.
Yes. You guys are going to have stinky feet.
Maybe I might, so.
Okay, so if we had to graph that really quickly, very lazily, where would I start? I would start at 3 on my y-axis. And from there I would do what? I could go up 4 over 1. 1, 2, 3, 4 over 1. Or I could go backwards 4. So go down 1, 2, 3, 4 to the left 1. That would get me another point that would also be on that line, right? And sometimes you may need to go backwards. If you run out of space on your coordinate plane, that may need to happen. Okay? So, can you find x and y intercepts and then graph?
Yes.
Can you find a slope and a y-intercept and then graph? Yes? I'm sure? All right, good. Now let's deal with point slope form. So here we have y minus 4 equals negative 2 parentheses x plus 3. I need to identify a point and the slope. Well, the slope's the easiest thing to identify. Which number up there is the slope? Negative 2. Good. Now, what would be the point?
Those would be 2 x1s and your y1.
Yeah. So the numbers I'm interested in are here and here. That 4 and that 3. And we do need to pay attention to the sign that is attached to them. Because if you think back, look back to your notes if you wrote it down, in point slope form, it was y minus y sub 1, right? So because this has a minus here, my y coordinate will be a positive 4. If I go to the x sub 1 spot, it was x minus x sub 1. Well, what type of number would turn a minus into a positive? A negative, right? So if it was x minus a negative 3, that's what would go to a positive 3. So my x coordinate of my ordered pair is a negative 3. Freddie.
So, you could just make that into the y equals x plus b.
Yes, you could distribute and solve. Yes, but if it's asking you for a point from it, then you'd have to find a point.
The line would be the same, right?
The line would be the same, yes, graphing wise. Yeah. Yep. Okay, so now let's graph that. Plot the point negative 3, 4. So 1, 2, 3, up 1, 2, 3, 4. From there, we're going to go down 2 to the right 1. There's your graph. Okay. So if it's in standard form, your best bet is to look for x and y intercepts. The only time it gets a little bit sketchy is when you start getting fractions as x and y intercepts, and then that might be easier just to solve it for y and put it into slope-intercept form. If you're given something in slope-intercept form, plot the y-intercept, do the slope. If you're given something in point slope form, you can pull out the point and the slope from that and then just graph it. Okay? Go with that? We're not even going to touch tables because I feel like that's just a waste of time. So now can we get to horizontal and vertical? All right. So, horizontal and vertical lines. Everyone always confuses these. Yes. Correct. So, let's first talk about vertical, because that's what I had listed up there first. Vertical lines go up and down, right?
Yeah.
What is the slope of a vertical line if it goes up and down?
And no solution.
Undefined, no slope, it doesn't exist, right? You can't ride your bicycle down that slope of a street. You could, but it wouldn't really exist. How would you even create a road that was like that? I don't even know. So vertical lines go up and down. Our slope is undefined. So you can either use the no solution sign or write out the word undefined. It's up to you. Okay. And it's always going to be something like x is equal to, in this case I made it x is equal to -2. I don't know where your line went. It's going to be x equals some number. Okay? Because it only has the same x value all the way through. Horizontal are lines that go straight across. What's the slope of that line? 0. And that's going to be the equation y equals, this one specifically is y equals 3. So it'll be whatever the x and y intercepts are. So let's talk x and y intercepts. Does a vertical line have an x-intercept? Yes or no?
Yeah.
Yes.
Right there.
It's right there at -2, 0 for this one. Okay. Does it have a y-intercept? No. No y-intercepts, not intersecting the y-axis. Horizontal lines do not have an x-intercept, but they do have a y-intercept, right? Okay. All right. Questions with that? So let's make sure we've got this down with graphing. So can you graph y equals 2?
Yeah.
What would that look like? So at our y-axis at 2, I'm going to put a horizontal line. Oh, and just a quick sidebar. If you do not label your units on the axes, I'm just going to assume that it's units of 1. Okay, does that make sense?
Yes.
But if your graph you need to jump by 2s, then make sure you label it by 2s so I know that you know what you're talking about. All right, so we can graph a horizontal. Can we graph a vertical? What would you do here? Move the 1 over, so we get x is equal to -1, which means it's a vertical line crossing my x-axis at -1. Okay? Can you graph?